Good morning everyone. So today we are going to start the first lecture of this course, ordinary differential equation. We begin with first order ordinary differential equation, that is we are going to discuss different methods to solve ODEs, first order ODEs, and once it is done then we will start the second order ordinary differential equation. So to begin with, let's see that what a first order ordinary differential equation is. So if I write down y dash is equal to yx, then it represents a first order differential equation. It means that if I have to write the generalized form, then either it looks like g of x comma y dash is equal to 0, or y dash is a function of x comma y. We have already discussed the order and degree concept in the previous class. So to begin with, let's start a very simple differential equation. Y dash is equal to y cos x. Now think over it that how we are going to solve it. So to solve it, the simplest way is I should use the concept of variable separable. What is variable separable? So if I write it as dy by dx is equal to y cos x, then you can easily see that I can take y on the left hand side and I can take dx on the right hand side. So this looks like dy by y is equal to cos x dx. So this is variable separable because on the left hand side you have a function of y only, and on the right hand side you have a function of x only. And now we simply integrate it. That gives me log y is equal to sin x plus c. I can also write it as y is equal to c e raised to the power sin x. Both the formats are correct. But the important observation is that how did we solve it and what should we call it? So we call it variable separable differential equation if you have a first order differential equation of the form y dash is equal to f of x comma y, where f of x comma y is given in the form f of x and g of y, then it is variable separable form, because once it is in this form it is very easy to solve it by taking the left hand side as a function of y only, right hand side as a function of x only, and then integrating on both the sides. Let's try to solve one more question which says that y dash is equal to sin x minus y. Now if you see this question, then it is not variable separable. You can try it by yourself, but the hint is, can you reduce it into the variable separable form? If it can be reduced to variable separable, then we know that how to solve the variable separable differential equation. So please think over it. So this is the idea, that if you have an equation of the form y dash is equal to f of ax plus bx plus c, ax plus by plus c, then it is a function of ax plus by plus c, and that's why you can take ax plus by plus c is some other variable t. Now differentiating on both the sides, you will get t dash as a plus by dash, and now y dash is f of ax plus by plus c, which means f of t. And now this equation becomes variable separable form. T dash is equal to a plus b f of t, and therefore you can separate the variables, and integrating on both the sides will give you the required answer. Now use the same technique to solve the differential equation y dash is equal to sin x minus y. So it is a function of x minus y, and therefore I can take x minus y is equal to t. That gives me, I need to differentiate both the sides. So 1 minus dy by dx, which is y dash, is equal to dt by dx. Now I have to substitute the value of y dash, which is given as sin x minus y, which is sin t. So that gives me t dash is equal to 1 minus sin t. Now it is a variable separable form, and therefore I can write it as dt by 1 minus sin t is equal to x plus c. Yes, now simply we need to integrate it. The integration is little bit tricky, but I believe that you have already studied such kind of the technique. So we rationalize it. It means we multiply and divide by 1 plus sin t. So this becomes 1 plus sin t, and the denominator becomes 1 minus sin square t, which is cos square t, and right hand side is x plus c. So this becomes integration 1 plus sin t divided by cos square t dt x plus c, which is same as integration 1 by cos square t is sec square t plus sin t by cos t, and 1 by cos t becomes tan t sec t, and you have to use dt on both the side is equal to x plus c. Now integration of the sec square t is tan t, and integration of tan t sec t is sec t, which becomes x plus t. If you replace the value of t again, so this is tan of x minus y plus sec of x minus y is equal to x plus c is the required answer. Okay, so we started with the variable separable form, which is the easiest to follow, and then we have seen an example where we can reduce the given equation into variable separable form. We can do one more exercise, or you can take it as a homework also, which says that solve the differential equation y dash is equal to sin x plus y plus cos x plus y. Again you have to see that can it be reduced to variable separable form. So to begin with, again the right hand side is a function of x plus y, and therefore you can take x plus y is equal to t or v, some variable. This gives me 1 plus y dash is equal to v dash, and now y dash is sin v plus cos v. So this gives me v dash minus 1 is sin v plus cos v, or I can say that v dash is 1 plus sin v plus cos v. So again you can see that it easily get reduced into the variable separable form. This means that dv by sin v is 2 sin 2 theta is 2 sin theta cos theta. So I can write sin v as 2 sin v by 2 and cos v by 2 plus 1 plus cos 2 theta is 2 cos square theta. So this becomes 2 cos square v by 2 is equal to dx. Yes, again it's a little bit tricky, but you need to practice all these techniques. To solve it further, I take cos square v outside, so 2 cos square v by 2, and this becomes 1 from here, and this becomes sin v by 2 by cos v by 2, this becomes tan v by 2, and the right hand side is x plus c. Now it's quite simple because this becomes sec square v by 2, so you need to simply put 1 plus tan v by 2 is equal to t, and that gives you sec square v by 2 1 by 2 dv is equal to dt. So solving it further, the required answer is log of 1 plus tan v by 2 is equal to x plus c, where v is x plus y. So in today's class we have seen two techniques. One is straightforward variable separable method, and the other is the equation reducible to the variable separable method. In the coming class we will see different techniques to solve the first order differential equation. Thank you very much.